All right. So Bex is Houdini's expression or code language. I was going to hold off a little bit in regards to talking about this, but this is like the big elephant in the room. Um, because if you can really master this area, you can really master a lot of areas of Houdini and take things to the next level. Um, so we're going to talk about this, even later in the class. We'll have some additional examples, but I wanted to get us at least started. I hope this isn't too complicated of a lesson, but we'll go through it. Okay, so first off, if you just Google something like Houdini wrangle attributes, you can see something like using Vex expressions. And here's another decent one, Vex wrangle cheat sheet. But I'm going to come to this Houdini one. If we come through this, we'll see lots of good stuff. We can see like the syntax, some gotchas like you have to use semicolons at the end of a line and so forth. So I'd highly encourage you to read over this. We'll actually be talking about radians a little bit today with one of the examples that we're going to talk about. Real quick though, I do want to talk about some attributes or some um, variables. So I do want to talk about some variables. And so there's different variable types. So float, that would be like a decimal point number. We can have a vector 2 that contains two floats. Vector 3, which you'll use this quite a bit. And this tends to have like position, right? We got our X, our Y, and our Z position. And now if we look over here, whenever we create an attribute, you'll see that for float, we're going to do f at, and then whatever we want the variable to be named. I don't do vector 2 floats very often, but that's how you would do that. Vector 3 floats would just be v at, and then whatever the name of the variable you want. So when we get into 4 floats, that's almost kind of like when you're starting to think about matrices and things like that. Just some things that contain additional data. Now it's not quite the matrix, right? We've got the matrix down here, and we could create different matrices and so forth. But we do have 4 floats, and so that would be like p at. I at would be an integer. So integers and floats are similar. Floats have decimal points. Integers are whole numbers. So yeah, and we got strings and so forth. But I wanted to point out this page, so take a look at that. Now, another thing I want to point out, if you kind of look for copy and instancing or geometry attributes, you should be able to find these pages. You can see that Houdini just already has some attributes out of the gate. We can create our own, right? That's what this is showing us how to do. If we wanted to create a vector 3 float, we would do something like that, v at name, and whatever that name is. But Houdini just already has some just natural attributes that come with it. So at p, at capital N, at lowercase v, and these are, so that's like velocity, normal, point, or position, the ID, the name, and there's p scale is like randomizing scale across like particles and things like that. PT num, which would be like a point num. So if you have a bunch of points in a scene, every one of those points is going to have its own individual number. So you could run a thing over all the points by doing PT num. So we'll do something like that where we create some random things across that. CD. So capital C and lowercase d, and do the at sign before that is like color and so forth. And so you can see there's a number of attributes. Now the thing to kind of watch out for, there's geometry attributes, size and rotation, viewport display even. But we also have these copy and instancing. So these are kind of some quick references to some that are used quite a bit. And so another thing I might show you real quick, let's pop open Houdini. This is an example that we're going to go over. And so Uh, we may type some of this code together, but this is kind of getting a little advanced, and so I don't necessarily need you to understand all of this in our first go. But I would like you to know how to get code, where to put it, how to run it, and that sort of stuff. So I'm going to give you this script. We'll talk about a little bit of it, and I'll try to I'll talk it through, but I don't know that we're going to type all of that out together. Okay. So what I wanted to show you, there's also, we can type code, and that's through, like, if we wanted to call it like a point wrangle, we can drop that down, and then we have a window. Now we can type code for primitives, points, vertices, and what does that mean? So if I drop down a sphere, I'm going to plug that into this point wrangle, and I'm going to turn this on. If I come over to the geometry spreadsheet, we'll see again we have points. So this is where if we create something with this set to points, it's going to create attributes here. But if we set this to, say, like primitives, well, it's going to create attributes in the primitives and so forth. And so you want to pay attention to this specifically and know where those attributes are going to land, because they could land on vertices or primitives or details and so forth. So let's look at something. So we can already see that the sphere has a position, and so let's just create our own attribute, and let's just get some numbers in here that we can see. And so, by the way, this is point num 0, point num 1, all the way to the total amount of points that we have. Okay, so if I did something like float at, and let's just call this number, is equal to 1.0, and don't forget the semicolon. And so if I did that, this would create an attribute for every single point that has a value of 1. Now we may want to do some things where we get a little more crafty and a little more clever with some of this and not have it like a value of 1 for every single point. We might want this randomized, or we might want some mathematical formula running over this or something like that. And that's where we start to write different expressions, the sine of something or the cosine of something, or even further than that, right? For a quick example, I'm going to type rand. So the random function, rand, is going to produce a random number between 0 and 1. And we want to do this for every single point number. So we're going to do rand at pt_num. And so when I click off this down, you can see, and if I organize this by right now it's organized kind of like by the point number, but if I organize it by the values, so you can see like it's kind of jumbled up in the order of the point numbers. But here you can see it will go across all the numbers and randomly generate for each number a value between 0 and 1. And so here at the lowest part, we can see we're almost at 0. And if we go down to the bottom, we can see we're almost at 1. So it just kind of goes through each number and just randomly generates a number between 0 and 1 for each one of those. Now that's great, but let's say we wanted to stretch that, right? So if we wanted the value 1 we wanted to fit it into a different range, like say, and we'll do this in a second, like if we're going to spin something 360 degrees, we might want the value of 1 to be 360. So we could do a fit range where we remap it and essentially stretch those numbers. So a value of 0 would still be 0, but a value of 1 would now be equal to 360. And a value of like somewhere in the middle, say 0.5, would then be remapped to a value of like 180. Okay, and that's kind of how that works. What I'm going to do is I'm going to run a fit range over this, and the way the fit range works is you take a number or a float, and then you put comma. And so this expression, this rand at pt_num, has given us a number. Okay, And now I'm just going to remap that between 0, comma, and 360 in parentheses. Now we'll see the lowest number is still close to 0, but as we go down, the highest number is almost 360 degrees. Okay, and keep in mind, this is a float. So we're creating a float attribute. So if anytime we type this at sign, we are creating an attribute. Or if we created vector, a v at, we'll just call it vec. And we could set like something that's like 0, comma, 1, comma, 0 in the parentheses and hit the semicolon. And now you can see, now we have a vector 3, because if you remember, I think it was over here, vector 3, v at whatever we want to call it, we get 3 different values. So the float will just give us like a single column, obviously, float number. That's what we created that. Now we have this vector where we've set everything to be like that. And again, we could do like, instead of 1, we could do rand at pt no. And now we're going to get this sort of stuff. And then we could even, again, we could fit range this into something. So you can do all sorts of stuff for each number. We could do something here, or we could do something here, and that sort of stuff. So I wanted to go over kind of quickly in this discussion the different types of variables, but also a couple commonly used functions where you do a random across all the point nums, and then you can remap that across different ranges. So the other thing to mention about vex is another thing we could think of is having variables like this with the at sign and things like that that become actual attributes. And these attributes will continue on if we drop down additional nodes. I'm just going to drop down a few nodes just so you can see this. So I've now got this null 1 selected, and we can see here we created this number attribute, okay, and we also created this VEC, so vec attribute. If I click on this null, we can see we have this number attribute and the vec attribute. So these attributes are carrying well beyond this point wrangle. And so we could have a variety of different things, transferring attributes from one thing to another. Math is changing this. These numbers could drive different simulations and so forth. So there's a gazillion things we can do with this. I do want to point this out though. So if I come back here, and so I want you guys to think of like v at, f at, I at, whatever is as creating variables that become attributes, or another way we could think of that is creating global variables that continue on. But we can create variables that don't live outside of this point wrangle node. And that can be helpful because this is all data that's going to be continue to be calculated throughout whatever we're doing. Okay, and this stuff can start to weigh down simulations and things like that. So if we want to be efficient, sometimes we don't want these to just be attributes if they're not needed to be. Sometimes we need them to be so it lives out and it does other things out here to other objects or whatever the case may be. But if we don't need that, we just need something to happen just in this point wrangle just to change something really quickly, we can also set local variables. And so the way we would do that is we could type something like float. And then, let's see, we could do like a float rand number, okay? And that could be equal to this whole expression up here. So we could copy this, paste it down here. And so this is actually doing the exact same thing that this is. It's just not living beyond this node, right? It's not creating an attribute for it that lives in the geometry spreadsheet. But underneath the hood, it is still doing the exact same thing. So, and the way we define these is, just like vector VEC, and that could be equal to that. And so this local variable is the exact same thing as this, is just local. And once we come down here, those local variables don't exist anymore, whereas these at attributes continue to exist. So hopefully that makes sense. So this was just kind of a quick introduction to Vex and just thinking about programming a little bit, more like expressions and things like that. But I'm going to actually break this up into two parts. We will look next at an example. This is probably a little early to kind of get into super in-depth stuff, but I want to at least talk about this and give you this code and let you know where to plug this in to get it to work. Not necessarily that you have to be able to type Vex at or code Vex at this level yet, but I do at least maybe want to talk it through so you have an idea of what's happening here. All right, so anyways, I hope this first part video has been helpful.